A many-to-many relationship allows end users to have multiple members of a dimension for a measure group. There are times when more than one label is needed to categorize measures like sales and gross profit. This could be a sales reason in an accounting database. Or it might be a diagnosis for a patient who could have multiple diagnoses for a single visit in a healthcare system. The use of many-to-many requires an intermediate fact table that, quote, bridges another fact table with a dimension table. This is where the term bridge table comes from. The bridge fact table does not have any displayable measures for a client reporting tool. The measure and measure group have to be created in an analysis services multidimensional cube. The measure can be as simple as a count of rows. The visible property is set to default for the measure, so the measure group or measure is not displayable. The bridge table is a fact table containing the primary keys of the related fact table and related dimension table. The data is the occurrence of the dimension member with the measure from the fact table, allowing many members for many fact measures. This is called an intermediate fact table in an analysis services cube. The data source view in this example shows the fact internet sales reason with two primary key columns from the fact internet sales order number and sales order line number, and it's part of its own primary key for fact internet sales reason. Plus, the primary key from the DIM sales reason key is included in that primary key with the other two columns in the fact internet sales reason. This structure allows multiple sales reasons to be associated with many internet sales, hence the term many-to-many. The new dimension for sales reason is created from the dimension table, and you add the attributes and hierarchies just like any other dimension in an analysis services cube. Here is an example of the data from the sales reason table. You can see the hierarchy reason type followed by sales reason, and the hierarchy is named sales reason by type. The new measure is created in a measure group will be for the intermediate or bridge fact table. The measure can be a count of rows for one of the columns. Make sure that you change the property of the new measure to false so it is not displayable to client reporting tools. The dimension usage of the cube in an analysis services project is where the many-to-many relationship type is configured. Sales reason in this example has a relationship type of many-to-many in the upper right with the dimension sales reason created earlier. The intermediate measure group is fact internet sales reason, and that was created with the bridge fact table. This is a demonstration of the many-to-many relationship. First, we're going to open SQL Server Data Tools. Once this is open, we're going to open up the project to start this section of the training. It's located in the Start Chapter 05, and it's called AdventureWorks DW 2014. The first step in creating this many-to relationship is to add the tables in the data source view. So we'll open the data source view. Here we'll highlight the internet sales in the diagram organizer, and we'll click in an open area of the work area. We'll right click, and in the menu we'll select Add Remove Tables. Here we'll find the DIM sales reason and the fact internet sales reason. We'll move these over to the included objects. After that, we'll click OK, close, and save our data source view. Next, we'll create the new dimension. We'll right-click in the Solutions Explorer under the Dimension folder and select from the menu New Dimension. In the Welcome screen, we'll click Next, and we'll make sure Use an Existing Table is selected. When we click Next, it'll have the data source view selected for us, but we'll need to change the main table. Here we'll select Dim Sales Reason. The key columns is the primary key in the data source view, but the name column is the same column. We'll change that to Sales Reason Name. Once we do that, we'll click Next. Here, we'll rename one of the attributes from Sales Reason Key to just Sales Reason. We'll also add Sales Reason Reason Type, and we'll remove one of the reasons from the description of the attribute. That's all we need for the Select Dimension Attributes window, so let's click Next. Here, we'll just take the dim off the name of the dimension and keep Sales Reason. Once we click Finish, we have a new dimension, but we'll have to go to the Solution Explorer, right-click the project, and deploy to see if we have any errors. Remember, always deploy your project after making changes in a multidimensional cube. After that, we can click the Browser button and see the Sales Reason and Sales Reason Type in a hierarchy drop-down. Here, under the All level, we could see the Sales Reasons as well as the Sales Reasons Type. Let's make one more change to the dimension before we continue to the cube. We'll go back to Dimension Structure, and in the hierarchy, we'll create a new hierarchy. We'll drag Sales Reason Type, which will create a new hierarchy in the hierarchy pane, and then Sales Reason under Sales Reason Type. We'll right-click on the word Hierarchy in the hierarchy name and rename it to Sales Reason by Type. Again, we'll go to the Solution Explorer, right-click the project, and deploy to make sure there are no errors. Once we're sure the processing completes successfully, we can go to the Browser button, and in the upper left in the toolbar, click Reconnect, and we should see our new hierarchy under the hierarchy drop-down. Once we select that and drill down from the All, we'll see the Type level and then the Reason level. Now we have some categorization for our sales reasons. Let's close the Dimension Designer and go back to Solution Explorer and double-click the cube. We have a couple things here to do. The first is to create a new measure group for the intermediate or bridge table. We'll right-click in the Measures pane, click New Measure. From Usage, we'll select Count of Rows. From Source Table, we'll select the Fact Internet Sales Reason, and we'll just click OK. The last thing we need to do is right-click on this new measure and go to Properties. The visible should be false, not true. We don't want to display this new measure to our reporting tools. Once we do that, we can go to the Solution Explorer, right-click the project, and deploy to make sure there's no errors in this new measure that we've created. After that completes successfully, we'll go to the Dimension Usage tab. Here, below the dimension list, we'll right-click under Internet Sales and click Add Cube Dimension. Here, we'll select our new dimension, Sales Reason, and then click OK. It automatically knows that there is a relationship, which is a regular type, between Sales Reason and Fact Internet Sales Reason, which is the measure group we just created the count of rows with. We'll click OK, but what we really need and want is the many-to-many with the Internet Sales measure group. If we go to that intersection and click the ellipse button, we'll change the relationship type from no relationship to many-to-many. Here it knows the dimension is Sales Reason. What it doesn't know is what the intermediate measure group is. That's the one we just created with the visible property set to false. We'll select that and click OK. Next, we'll have to deploy our solution to make sure there are no errors. Once this is finished and deploying successfully, we'll go to the Browser tab and we'll make sure that our new created measure and many-to-many relationship is valid. In the toolbar, we can click Analyze in Excel and select what perspective or cube we want to use. Once Excel launches and we enable it to bypass the security, we'll select Internet Sales first. You'll see the total Internet sales is a little over 29 million. I'm going to also add from the order date the year to rows. This will show us the row by year and its total of sales. If I do a sum of those columns and intersections of rows, we'll see the same value here that we also see for the grand total of the pivot table. I'm going to highlight the pivot table, copy it, and paste it below. And in this pivot table, I'm going to remove the year from the rows and find sales reason. I'm going to drill into the more fields of sales reason and drag our sales reasons to the row. I'm going to do the same sort of sum to the right of these columns, and you'll see that that total now is over 30 million. This proves that the sales reason is related to the internet sales more than one time for some of these values in sales reason. You'll also see, though, that the grand total stays the total of actual internet sales and does not reflect the many-to-many relationship. Now we're going to talk about some advanced calculations. Part of the power of using a multidimensional cube are these calculations. Here, the developer can create embedded measurements that are able to be sliced and diced by dimensions and their attributes and hierarchies. These calculations are usually based on other measures. Advanced calculation uses MDX, multidimensional expression language, in the calculation section of a cube. You will learn more about MDX in that section of this training. With dimension and hierarchies, ratios can be used to compare parent levels. The subcategory level in this example, its measure can be divided by the parent level category as an aggregate. The encapsulation of this measure in the cube helps eliminate the calculations being specified in a report and helps reduce errors in those calculations. A scope statement can be used to create a subcube of the overall cube. Then, in this subcube, you can scope detail measure values. If we want to apply a percentage to a measure only in 1 quarter or 1 year, here's where we can do that. The freeze statement can be used in addition to the scope to further enhance the values reported by the scope. The ratio to parent is a great example of using an advanced calculation. You could take the lower level of a hierarchy, no matter how many levels are there, and divide by the parent of that level and recalculate the measure. In this example, you can take the category level of internet sales and use as the denominator in the ratio calculation of subcategory. The calculation can go even further and look at the root of the dimension product in this example. Then a different ratio can be used and calculated for all products rather than just the levels in the hierarchy like category and subcategory. In this example, the root of the product dimension is used as the denominator. Say the sales manager wants to increase the sales quota of a quarter or year but not affect the annual quotas, just to give a little motivation to the salespeople. This is where a scope statement can be used. The scope statement can increase just 1 quarter of 2013 for the sales quota measure. Here we also have a new relationship in the sales quota is quarterly and not daily. In this demonstration, we're going to look at advanced calculations with the ratio to parent and product, as well as using the scope statement. First, we'll launch SQL Server Data Tools. You can do this from an icon or from your Start menu. We'll go to the File, Open Project Solution option and go to our Start Chapter 5 solution, AdventureWorks DW 2014. First, we're going to add a new calculation. We'll go to the Solution Explorer, open up the cube, and under the Calculation tab, we'll create a new calculation. We'll click on the last one created, right-click below it, and click New Calculation. The name will be Internet Ratio Sales to Parent. It'll be in the parent hierarchy measures, and we'll build the expression. First, we'll use a case statement and then start it with the when clause. Here we're going to see if we're at the top level of the hierarchy. If we are, the ratio will be 1. In the lower left, under Calculation Tools, we'll scroll down to the product dimension. We'll drill into the product by category hierarchy, and we'll drag that to our expression to the right of when. Here we're going to add some functions of MDX. We'll say current member dot level dot ordinal. You will learn more about the MDX functions and expressions in another section of this training. Here we'll say when that equals 0, meaning we're at the top level, then we're just going to have a ratio 1. Else we'll do the calculation. Here we'll first pull the internet sales amount. We can go down to Calculation Tools, drill into Measures, Internet Sales, and drag the internet sales amount across. Next, we'll divide this by an intersection of the product dimension with that internet sales. We'll grab that same current member for the products we used above, paste it down, and we'll put the parent here. So it's going to look at the parent of this current member that you're displaying, and it's going to grab the internet sales from that. And we'll close the parentheses and then end this case statement. We'll go to Solution Explorer, right-click the project and deploy to make sure we don't have any errors in that calculation. And if it deploys successfully, what we're going to do next is make sure that the other properties of this calculation are set. So in the format string, we're going to replace a blank with %. We'll make visible true. Our non-empty behavior will be internet sales amount, and then our measure group will be internet sales. We'll save this and deploy. Once it's finished deploying, we can go to the Browse tab and look at the results. We'll click the reconnect to make sure we're connected to the currently deployed cube. We'll drill into Measures, the Internet Sales area, and we'll drag the ratio to parent. Here it should be 1 because there are no levels of product. Next, we'll go down in the measure groups to product, to our product category hierarchy, and we'll drag that across. Now you'll see the internet ratio calculation, which looks to be about 2% or less for each individual product. So the sum of all these is the mountain bike parent ratio. But what we'll do is we'll remove product from this display, and we'll see a better display of the ratio. Here we can see that 35% is mountain bikes for the bike category, 51 for road bikes, and about 13.5 for touring bikes. These will sum up to 100%. If we want to see the internet ratio sales to category, we drag subcategory out, and then we'll see that bikes is 96% of sales. This is a very powerful calculation for inside of a cube, and it shows why you'd want to use a multidimensional cube. Next, we'll go back to calculations and we'll create another calculation. This one we're going to call internet sales ratio to product. We'll go to the expression and we're going to drag our internet sales out again. But this time, what we're going to divide by is going to be a function called root. And in that root function, we're just going to look at the product dimension. So here, it will always go to the root of the product rather than to the parent, like in the previous calculation. One thing we need to add is a parenthesis before root, so the intersection of the root is at the internet sales amount. We'll change our format string to %, visible true. Again, our non-empty behavior will be internet sales amount. And lastly, we'll put it in the internet sales group. We'll deploy the cube. Once it deploys successfully, we can go back to the Browser tab. Make sure we reconnect to the cube. And this time we'll drag both of those measures out. We'll drag the internet sales to parent as well as internet sales to product. And we'll notice here it's 1. Now we'll go down to the product dimension and we'll drag that hierarchy out again. And you'll notice now that the ratio for the to product is a lot lower than the parent. That is because it's to the overall product dimension rather than its parent. And as we drag levels out of the hierarchy, those numbers will get closer and closer until at the end, when we're just at the highest category, they will be the same. That's a demonstration of these calculations.